Okay, so we're doing a tree diagram, and the question is, what's the probability that Bob and Sally both win? Now, there's more than one way to do this, but I'm going to show you the way that would work every time. You go to the answers here, and you look for the ones where Bob and Sally both won. Now, Bob and Sally, I'd ask myself this question. Is this one of my answers? Look back on this branch. There, there, there. Did Bob and Sally both win?
Yes.
Yeah, because it was on that branch.
Yes, Bob.
Okay. And how about on this one? Did Bob and Sally both win?
Yes.
Yes. So what do you do to them if you get multiple answers that are right? If you multiplied them, they would get incredibly tiny, and that doesn't make any sense. You would add them together, yeah. Because either this one or that one, Bob and Sally won. So your final answer on this one would be you'd add the 0.168 to the 0.072. All right, I'm going to give you another one like that. And this time, I want you to formulate what you think the answer is by writing down. Okay, stop talk. You're interrupting like 3 times now. I know you're having fun, but it's not. I'm not having fun now. You got to stop. Okay, so back to, I'm going to ask you to write down the decimals you should add together to give this answer now. Now, try to ignore those red lines because this next one is not going to be following those branches. All right, this next one is, would you please find the probability that Mick and Bob won? So you're going to write down the decimals that you think should be included in the answer. Mick and Bob won. Now, just to clarify, I didn't say anything about Sally. I don't care if she won or lost. Doesn't matter. I just said Mick won and Bob won. That's all I said. Find the probability that Mick won and that Bob won. Was this one of the answers? The one I just put a blue line on there? Is that one of the answers? You just have to ask yourself, did Mick win and Bob win in that one? Yeah, so that's one of the answers. Is this one I got the green arrow to? Does that one where Mick won and Bob won? No. Because Mick didn't win on that one. So you don't include that one. All right, figure out all the rest of them that you should put into your answer, and then actually add them up. You need a calculator for this test, so I'd like you to have a calculator out right now. Get a calculator out, please. Now actually add up those decimals. You need to borrow a calculator. I have calculators. If you want to put it on your iPad, that's fine. Do it quickly, please. I don't want to actually review all hour. That would just bore the heck out of you. I'd like you to have time to ask questions from the review. So again, the question is, what's the probability that Mick and Bob won? So, what was another possible answer besides the 0.168? 0.392. Can you guys verify that that's another one? 0.392? Because on the 0.392, Mick won and Bob won. Are there any others where both Bob and Mick won? No. So that's just those two. So put them together, and you got a grand total. All right. What is the final answer, Brendan?
0.56.
And you guys verify 0.56? All right, 56% chance. Okay. Now here's a more complicated one. Given Sally lost, all we know for sure is that Sally lost. What's the probability that Mick and Bob won? Now, as soon as I say given Sally lost, you just have to divide by a different denominator. You didn't even divide last time because it was out of everything. This time it's not out of everything. Only certain answers are possible. So given Sally lost, what's the probability that Bob and Mick won? So what you're looking for first is which are the ones that are possible. And you're going to add those all up and put them on the bottom. Is this one where Sally lost? Nope. Is this one where Sally lost? No. Is this one where Sally lost? Yes, so that's one of the possibles. 0.392 is one of the possibles. Plus, are there any more possibles? Sure. Is this one where Sally lost? Yes, so we include that. We're just doing the possibles now. And the only thing that we know is that Sally lost. Is this one where Sally lost?
No.
Nope, because she won. You can see right there. All right, is this one where Sally lost? Nope. Is this one where Sally lost? Yes. Is this one where Sally lost? Yes, because right there it says she loses. And then what we wanted, but only from the possible ones. See, like, I know some people are going to include this in their answer because they were like, put Bob and Mick won, but that wasn't possible because we know Sally lost. That's not possible. So of the possible ones, which were this and this and this and this, what's the ones where Bob and Mick both won? I don't see a 492. Can you repeat that? 0.392. All right, double checking you. Yes, that's the one. There you go. From there, it's easy. You guys can add decimals and divide and stuff. All right, but this is what you needed the extra practice on. Now, there's Venn diagrams, which I think are easier, and there's also the chart kind. So, before I move on, because this is probably the hardest kind, do you want another practice of this kind, or do you feel like you're good? Or, all right, I'd like you to give me I think we should do one more of these. Raise your hand if you think we should do one more of these. All right. I see some people were looking around to be like, maybe we shouldn't. I'm going to do one more anyway because there were a couple people that expressed interest. All right, one more. Given, this is going to sound more complicated, but it's really not. Given Bob and Sally never lost, what was the probability that Mick lost? Given Bob and Sally never lost, what's the probability that Mick lost? All right, so the way you should do this is figure out what you want goes on top and what's possible goes on the bottom. So first you do the possibles. Given Bob and Sally never lost really also means that they won. And so is this possible? Yeah, because they won on that one. And this is also possible because they won in that one, which is 0.168 plus 0.072. Raise your hand if you had the bottom right. Cool. Then, what's the probability Mick lost? Well, then we want that one. 0.072 goes on top. Now, there's other ways to do these, but this way will always work, and this is what I would suggest that you do. Take which is possible, put them on the bottom. All right, now, we're gonna go on and do a Venn diagrams question. This is gonna be apples, like you like apples. This is going to be fish. You have caught a fish in your lifetime. When you went fishing, you caught a fish once, at least, maybe more than one. And last one is you've been to Florida. I have no idea how many people in here have been to Florida, but we'll find out in a second. It's a small class today, so please copy this chart down and then think to yourself, where are you in this chart? If there was a big, good-looking apple and you were hungry, would you be like, yeah, I'd eat that apple? Have you ever caught a fish? And have you been to Florida? All right, there's no wrong answers here, it's just where are you? All right, if I describe this, are those the people, I shouldn't say it that way. Is that spot people that like apples?
No, people that only like apples.
That's a better way to say it. Those are the people that only like apples. They haven't caught a fish and they've never been to Florida. How about this spot on the outside here? People haven't done any of them, or they don't like apples, and they haven't caught a fish, and they haven't been to Florida. All right, so who's in, and I'm going to ask it this way to try to teach you better. If I just say, how many of you have, at some point, caught a fish, is that going to go right here? No, it's going to go next to fish, so we can use it later. All right, so let's do that. How many of you, guys, keep in mind, if we give me the answers incorrectly here, the graph won't work. Like if you say you never caught a fish and then later you say that you did catch a fish, then the numbers aren't going to work here. So be very careful. Think through. How many of you have caught a fish? Raise your hand if you have caught a fish. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Now we don't know where to put them yet though, right? How many of you have caught a fish and like apples? 1, 2, 3, 4, 5, 6, 7. You just can't change your mind. Okay, keep them up. Raise them high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Do you know where to put that? Not completely. This was fish and apples. You like both. As in you've caught fish and you have eaten apples. All right. Then how about the last one? How many of you have done all three? Oh, dang, this was not good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, where does that one go? Middle. And it does tell us something. Because wasn't these two also 16? Together, weren't they 16? So then don't you know what to put in the top one? It has to have to be 3. And then what does that mean about this spot? 0, but this spot? 0. Okay. I am surprised how many people have been to Florida. I guess Minnesota and Florida is a good combo. A lot of people do that because it's cold here and then they want to get someplace warm. So. All right. How about if I just fill in the rest of them to save us time? Let's say I put in a 1 here and a 2 here and a 4 here and 1 there. Okay. Please copy down the rest of the numbers. And now, here's my question. I grab a random person. What's the probability that they've caught a fish and been to Florida? Fish and Florida. And again, I made up the rest of the numbers, so this is not going to add up to the total of people in this class. That's okay. Fish and Florida. Now, it really comes down to what the word and means. I think I said how many at one point. I don't want to do that. This is a probability that I grab a person and they have caught a fish and have been to Florida. I didn't say or, and. All right. Fish and Florida. Is that a really big answer or a smaller answer? Smaller. You got to know the difference. Or has big answers and has smaller answers. All right. So fish and Florida. Now the people that have caught a fish and been to Florida is 13. And I know you might be like, but that's the middle one. Yeah, but all the people in the middle have caught a fish and have been to Florida. All right. Over the grand total, which I should add up right now, 13, 16, 17, 18, 19, 20, 1, 2, 3, 4, 24. And again, I made up these numbers at the end. Raise your hand if you had 13 out of 24. Okay, good. Any questions? Yes. As long as your pass, bring it up here, shows that you're free to do so on the hub, I will say yes. All right, now I'm going to change it a little bit. Given that I only talk to people who have caught a fish, what's the probability that they like apples? Given fish, yes. Good. Given fish, what's the probability of apples? All right, as soon as I say given fish, it's not out of 24 anymore. If I was only talking to people who have caught a fish, it's out of 16. Raise your hand if yours was out of 16. Good. And then probability apple. Well, I have to now look at the people that are possible, which are only inside the fish circle, and then pick from those. And it's all 16. Raise your hand if you had that one right. Nice. Okay. Next. What's the probability if I grab a random person? Remember, random means it's out of everybody. If I grab a random person, what's the probability that they like apples? Remember, it's out of 24. Grab a random person, probability they like apples. Remember, this is always what you want out of what's possible. And in this case, the possible, there was 24 things that could have happened, 24 people that you could have picked. And what you want is the people who liked apples, which is 16, 17, 18, 19. Raise your hand if you had 19 over 24. Awesome. Now, people a lot of times pick the one because they're like, that the one is apples. I didn't say they only liked apples. I said that they liked apples. All right. Now we got to use the or. Remember, our or, big or small answers. I'm going to give you this example. You win if you have hair or you breathe. Jeez, and that's everybody. Okay, so it's going to be, ors are big answers. So, what's the probability of fish or apples? If I never said given, then it's out of 24. What's the probability fish or apples? If caught a fish or they like apples. Remember, or is big answers. If you haven't written that down somewhere, expect to fail this test. All right, because it gets really confusing, the or and the and thing. Or is a big answer. So you ask yourself, they just have to either like apples or have caught a fish. So it includes everyone in the apples and the fish category. So like 1 and 3 and 13 and 2. So 16, 17, 19 out of, did I say given anything? No, 19 out of 24. Let me just give you an example of how it can be really small. What's the probability that they like apples and fish and Florida? Apples and fish and Florida. Well, then that'd be 13 out of 24, wouldn't it? And that's a pretty small answer compared to 19 out of 24, right? Okay. Ors, big answers. Always go back to that example of like, you win if you have shoes or you're breathing. Okay, now everybody wins. Ors are big answers. Okay. I think we should move on to the chart kind. Everybody copy this chart down, please. Lefties, righties. Shake it up from the dog or cat. If you were forced to pick because you were getting a vote and your family is going to get a new pet, would you pick iguana or ferret? Now, I'm going to do something kind of strange to increase my number of lefties because I think how many lefties in here? Raise your hand if you're a lefty. Okay, so then, you know what we're going to do? We're going to actually make it a poll. This is for more fun. Left and right is going to be changed. Everybody change the left and the right. We're going to say people with dark shoes, people with light shoes. Who is somebody that has dark shoes and would pick an iguana? Raise your hand for dark shoes. You have dark shoes on and you would pick an iguana. 1, 2, 3, 4. Raise your hand for you have light shoes and you'd pick an iguana. 2. How about you have dark shoes and you'd pick a ferret? 1, 2, 3, 4. And light shoes and you'd pick a ferret. 1, 2, 3, 4, 5, 6. All right. Then I'll add them all up for you. 4 and 2 is 6. 6 and 4 is 10. Add these up as 16. It should add up the same way the other way. 8 and 8. Look at that. It adds up to 16. Okay. So then, first question about this. Remember, it's what you want over what's possible. If I only talk to light-shoed people, what's the probability they would want a ferret? Just write it down. It's a fraction. If I only talk to light-shoed people, probability they'd want a ferret. Did you have 6 out of 8? Awesome. Given I'm only going to talk to the iguana people, what's the probability I grab one of the random iguana kids and they have dark shoes? Given random iguana kid, probability of dark shoes. Get 4 out of 6, which reduces to 2/3. Okay, good. Do you need any more on this kind? All right, seeing pretty much nobody needs more on that kind. So we've done all 3 kinds. And now you have a bunch of work time. And during that work time, you have a practice test and a key for it. And you should do practice problems that scare you. All right? And if you get stuck on anything, you should come up and ask me, and then the test is tomorrow. You should really do that studying for the test right now while you got somebody here. Because if you're studying tonight and you get stuck on number 4, I'm not going to be able to explain it to you tonight. I can explain it to you right now. All right, that's all I got for you for today.